Hello, can you hear me? And can you see my screen? Okay, okay, so let's start our today's training. Today I will introduce some commandly happens error in our feedback from our clients. And I will introduce how this error, why this error appeared, and how to solve this error. Here I will first introduce the difference of our error or fault and alarm. And then I will introduce some different category of our error. And then last, I will introduce some false analyze. First part is about the difference of our error and alarm. First, you can see there are four types from category 1 to category 4. The alarm or the error level is become lower. And here you can see for first three type error, the motor will directly change to stop status when this error happens. But for category 4, when this level alarm happens, the motor can keep running. And here clear means here for category 1, when this error happens, we can't use P10 and 2. We can't use parameter to clear the error. We need to first we need to check and solve the error, and then we need to repower. Yes, but for error 2, for level 2, 3, and 4, these three error we can clear it when we solve it and without repower. This is error code and alarm code and error code. So you can see our panel can only display one error or one alarm. But if there are maybe many error happens at the same time, maybe 2 or 3, the panel will show the highest level of our error. For example, if we have alarm and error at the same time, our panel will display error on the panel. And here for the other errors you can check it through our SC tool. Here I have some monitoring value about the error from U1 and U1 22. Yes. And also you can use this function to check the current error. How to here we need to notice we need to solve the error first and then clear the error or clear the alarm. And there are some ways to clear the error. First one is use SC tool to set function codes P10 and 3. And the second way is use our panel to clear it. Also, you can use DI to clear the error. There are one DI function codes which is used for clearing the error. And then last, you can also use Modbus communication to clear the error. Use Modbus communication to control this P10 and the 3 parameter. So here, as I said, if our server have alarm 84, this alarm means need to repower to take the change rate parameter take effect. But if we don't want to repower, we can use Modbus to clear this error. Then you can use the motor continue without repower. This is SC2 clear, Modbus clear. And here have the lists of our error and the alarm code. Here. Okay. Okay, so now we know there are totally four level of our error and alarm, and the some of them can continue can be clear without repower, and some of them will make our motor stop directly when the error or alarm happens. It depends on the error level. And now we can check some error in category 1. First one is error 2. This error means the parameter storage have error. It means we can't set the setting parameter to our driver. This error usually happens when you upgrade the firmware of the server. Maybe there are some the cable is loose, or you power down the server during updating. So this error may happen. So you need to update or upgrade the server again. And this is one condition. And another one situation. And then the other situation is here you can see for VD2 SA series, if the firmware is smaller or earlier than V1.14, and for VD2F, if the firmware is earlier than V1 and V1.02. For these two, please upgrade the server firmware to solve it. And the last situation is our EEPROM of our driver is damaged. So this error will happen. If this happens, we can only change the control board of our driver. So why this EEPROM will be damaged? As I said, if we use Modbus to write the value to our EEPROM, very frankly, the EEPROM will be broke. Yes. So we please notice, don't use Modbus to write value to our driver very frequently. And here have alarm A91. This alarm is added to protect our EEPROM of our driver. And this alarm is only only the firmware is V1.19 or above have this alarm A91. And this alarm is used to, for example, if we write value to EEPROM very frequently, then this alarm will happen to tell you you should stop writing continue and check it. And the next for error 4. This error usually is a hardware question. If this happens, you can first try to only connect a power cable. I mean power supply cable. Only connect this cable and try to repower. Sometimes maybe 5 times or 4 times. And if these errors tell here, I can say it must be hardware question, and you can contact our technical to check, and usually this need to replace the control board. It's usually a hardware question. And the next error is error 26. This error means motor code is wrong. And in our last class yesterday, I said this error will happen if the error have a wrong motor code or have no motor code. So for this error, we can use our this manually setting motor code function to solve it. And how to set the steps is here. First, set. Let me check. First, we need to set P10 and 5 as 1, and then we need to set the here. Oh, sorry. First, we need to set P10 and 7 as 1, and then we set the code to P10 and 5. 2 steps. And here, this one is overcurrent alarm. For this, error. Overcurrent error. For this error, there are many possible reasons will cause this error. For example, the order of UVW connecting is wrong. Please check. We must connect U to U, V to V, and W to W. And second, maybe there are short connects between our UVW and ground. So please check if there are short connecting between UVW and the PE terminal. And also if our bucking resistor have question, we also make this error appear. So we need to check the bucking resistor. And for here, bucking resistor usually we need to check the resistor value. Our built-in resistor value is 50 ohms. And later I will have a picture show you how to connect. How to check the built-in resistor value. And the last situation usually will cause this error is our motor's acceleration or deceleration is too big. For example, we speed up the motor from 0 RPM to 3000 RPM within 1 second or within 100 ms. In this condition, if our load is big, then there will have a big how to say? It will maybe cause this error 20. So in this condition, we need to reduce our acceleration and deceleration and check again. Error 26 is about encoder connection. Usually, encoder connection have error must be servo side or motor side or the cable side. So we can directly to change server or change cable or change motor to confirm which part have question. If the cable is question, we can directly change another cable. If the motor side or driver side have question, we need to check the connector terminal to check whether it is damaged or have some connecting question. Maybe the connect is too loose or some, yes. So we need to check it. And for this error, usually is hardware side have error. It have no how to say, it had nothing to do with our firmware. Okay, now let's check category 2. For example, error 22. Error 22 means the input power is over voltage. Over voltage. You can see here is our normally range for 220 voltage driver. The bus voltage should be smaller than 390. And for 380 driver, the bus voltage should be smaller than 680 voltage. So when this error happens, we must we need to first check the input voltage is normal or not. Maybe there are some questions about our input voltage. It's too bigger, or it is not stable. Sometimes it may be changed to a very big value and cause this error. And the second, if we can confirm, the input voltage is normal, then we need to check our bucking resistor. And check it is connects normally or not, and check it is resistor value is 50 or not for our built-in bucking resistor. And also the acceleration and deceleration of our motor. So you can see they have for many error we may be caused by same reason. For example, if the bucking resistor have question, it may cause this error 22, or it will cause error 2020. Yes. And error 31. Error 31 is about power line disconnection. It's similar to encoder line disconnection. This error is also have nothing to do with our firmware. Usually it is a hardware side question about connecting. So here, first, same, we need to change driver or change motor or change cable to confirm which part have question. And if it is happens in driver motor side, maybe there are some question inside the motor. We have met before some case. So in this condition, you can contact our technical to confirm it. And if it is motor side question, we have to change or replace a new motor for it. F3. L21. L21 is under voltage, and the L22 is over voltage. These two difference. So here also you can see the normal range of our bus voltage for 22 for 220 voltage driver, the bus voltage should be bigger. Should be bigger than 200. And for 380 voltage, the bus voltage should be bigger than 420. Otherwise, this error will appear. So for this error, first thing we need to check the input power is normal or not. And the second, for VD2A type driver, when you power off, the panel will display error 21. And after about maybe 4 or 5 seconds, this error will disappear. And the next time when you power on, this error will not here again. Because after we power off, the system or our driver will detect the bus value is 0. So it will have this error appeared. So, what I want to say is, for example, if we power on the driver and this error appeared, and then we power on the driver immediately, this error will still displayed here. Even though our bus voltage have already changed back to our normal value from 0 to normal 1. Like this. Sorry, here. First, normal voltage, and when we power off, error happens, and we power on immediately. This error will still here, even though our normal our bus voltage have already be a normal value. Okay. So for error 21 and 22 is usually caused by our input power. And here, error 23, this error is about our bucking resistor. It's not connected. Not connected, maybe you didn't connect it, or you connect it, but it is damaged. So this error will happen. How to check the built-in bucking resistor? As this picture, you can see we need to put the multimeter to P pulse terminal and the D terminal. First, we need to remove the connecting terminal about this part, you can see, and then we check the resistor value between P pulse and terminal D, and you can see here normally it should be 50 ohms. If it is not 50, then the built-in bucking resistor have question. So you need to here you need to connect an external bucking resistor, or if you have or also you can remove the you can change the built-in bucking resistor yes. And if you want to connect an external bucking resistor, please remember to set this parameter P0 and 9 as 1, and this value default is 0. Okay, and also here you can see for this type, for this model driver have no bucking resistor. It's the spare parts. You means in our servo driver package, right? Replacements. As I know, we didn't have this in our package of our driver products. So you can buy it or buy one from local place. And as I said, for A type, the bucking resistor is 50 ohms and 50 watts. And for B-type, it is also 50 ohms and 80 watts. This is for built-in. So you can, yes, for B-type and A-type it's different. But if the built-in bucking resistor is damaged, why will it damage it? Usually it is because the power of the bucking resistor is not enough. So I think if you connect another new bucking resistor, can't solve the question. Maybe after run sometimes this will broken again. So I think when this is broke, we need to use the SC tool to calculate how much the power of our resistor is need and we connect an external bucking resistor. Yes. The arrow 34. Arrow 34 means motor overload. And there are another arrow 30, not this one, 36. For these two arrow will happens when the load of our motor is too big. For example, for arrow 31. Arrow 31 means our arrow is run in overload status for a long time. Then this error will happens. For this error happens, we can use P10 and 4 this parameter to improve it. Yes, if you remember in last class we also introduced this parameter. This parameter is the if we increase this value, then we can delay the time the error happens after the motor run in overload status. So the bigger this value is, the longer our motor can run in overload status. But if you want to increase this parameter, as I said, you need to ensure our motor will not heating up continually. For example, if the motor temperature is in a normal range, after run a long time, then you can try to increase this parameter. Otherwise, please not, because we need to check maybe our motor torque is not enough to drive this load, or your setting acceleration is too big, too bigger. So our motor have no enough power to drive it. Can take in. Yes, we have. In fact, we have do some tests about this, and I will share Excel table to our training group. For example, for different motor, and after running maybe 1 hour, 2 hour, 10 hour, and it is normal temperature should be which one? Okay, I will send it. Yes, and normal is normally for our motor to have a temperature more than 100, maybe 150, 115. Yes. May you repeat how me sure the motor's temperature? Just check the offset of the motor. directly use, but here you need to use some temperature measure tool. Yes, maybe some meter to check the motor temperature. Yes, from outside, it means wait. Oh, yes, surface, motor surface temperature. For normal temperature, we have test. It depends on the running time. First, it depends on running time, and the second is depends on whether you connect the motor to how sorry. Will also depend on how you connect the motor to the loads. Because for different connecting, there maybe have different how to say touch. Sorry, sorry for my English. And it will also depend on content area between our motor and our loads. The bigger content area is, our motor can, how to say, can have more ability to hit this patient to cooling. Yes, and I will share the table. Normal temperature. After training, okay, I will find that table and send it. Okay, so let's continue. Okay, so here, uh, let's turn back to this arrow. First, here the lot is too big. For this, maybe we need to replace a bigger motor which have more torque to drive our lot. And the second is maybe our acceleration and deceleration is too big. So we need a bigger torque to achieve a bigger acceleration and deceleration. And the bigger torque maybe will cost our motor our load. And also if you speed up and slow down very frequency, like this may also cause this error. And also here other reason, for example, unreasonable parameter. In our this course day, I have introduced about how to do automatic turning of our driver to set the initial ratio and to set the regulatory level, as if you remember. So if those parameter set is not suitable will also make this error happens. So first we need to ensure our control parameter is a how to say is a suitable value. So you can use automatic self-tuning to get the recommend control parameter. And also here, for some motor is with brake device. So if the motor with brake device, we need to give 24 voltage to our bucking device to make it release our motor. Otherwise, when you run the motor, the bucking device will always hot the motor axis and make it overload. For here, arrow 36. Arrow 36 means the position diversion is too large. What's position diversion? What's the position diversion? This arrow will only happen in position control board because for example, this is our command, our speed command, maybe VT curve, and this is our instruction curve and normal or our actuary speed model speed curve, maybe like this one. So you can see there will be a delay between the instruction commands and between instruction command and our actual voltage. So if this difference we will have a position difference, because the speed is different, so we will get our position arrow bigger and bigger. And if it is too bigger, then this error will happen. So why will this happen? There are many reasons. For example, this, if we didn't open or we didn't trigger this bucking device, it will halt our motor and make it can't rotate. But maybe our instruction is always sending. But the motor of our the position of a motor is always 0, 0, 0. So you can see the diversion is bigger and bigger. And when it is achieve some value, then this will happen. And also maybe the input pulse frequency is too bigger, and will also cause this error. Because for our driver, we have a limit about the input pulse frequency it can receive. If it is bigger than our limit, then it where this error happened. Okay. Oh, here, this is the arrow I said. When the diversion position is bigger than this error, this value, our driver will report an error. This is 60,000. For example, if we set our motor PPR as 10,000, it means when our instruction position is bigger, instruction position reduce our motor position is bigger than 6 tons. This error will appear. So you can see we can increase this value to make this error happens. how to say, slowly or delay this error happened. But if we didn't solve the question, the error position diversion will always bigger, and in some moment it will finally achieve this value and cause error. So we need to find the question, but not just adding this value. And errors 37 is similar to 34. It's also about torque and abnormal. You see the load is too bigger and unsuitable control parameter, and also the connecting order of UVW. This we have just introduced just now, and also this you can see parking device not open will also cause it. Here, if you remember, in our torque control class, we have introduced this forward torque limit and the reverse torque limit. So if we set these two limits too small, we also make this error happen. For example, maybe we need 50% rated torque, 50% rated torque to drive our load. But if you set these two parameters as maybe 40, so the torque will be limits in 40 and the wrong, and if the running time is bigger than this value, then the error will happen. So you can see in this condition, first we can increase this time, and second we can increase the limit of these two. And here for error 40, is about the encoder battery. And I also have introduced this parameter before. I said if we want to use a multi-turn motor as a single turn motor, we can set one parameter to ignore this error. So even though we didn't connect a battery for our encoder cable, this error will not appear. So we can use it normally. And here have some steps about how to replace the battery. Here have a picture. You can see here. In this picture, the battery is like this one. In this box. So we just open this box and remove the old battery and insert a new battery. Here you can see have two cable. Here have two cable, and these two cable is positive and negative terminal of our power. And here you can see here these two red one and this one green one, I think. Yes, these two cable is from our encoder cable. Sorry, what do you mean SPCS? You mean how much the voltage should be, right? We usually connect 5 voltage battery for it. 5, yes, 5, and when it is smaller, it is smaller than 3.1, this error will happen. And for our cable, normally for our encoder cable with this battery, it can work about 2 or 3 years normally. So you don't need to change the battery many often. I mean, because when servo is power on, when servo is power on, this our multi-turn motor or multi-turn encoder will use the main input power to work. So I mean, this battery will only work when the driver is power off. It will continue to work to make the multi-turn encoder to work. And the part 5 is about category 4. For this type 4 is usually some alarm. And for this alarm happens, our motor will continue to run. Yes. Here for alarm AT4, it means we need to repower to make the change rate parameter take effect. And as I said, just and we discussed before. Just now we have 4-way to clear error to solve this alarm. And the alarm 89, it means we have same configuration about DI ports, because we can't set 2 DI with same function code. Otherwise, this error will happen. And alarm 92. Alarm 92 is about encoder battery. If the battery value is smaller than 3.1 voltage, this alarm will happen. Okay, and the last part, I will introduce some normally happens question and how to solve it. First is servo driver panel displays abnormal. For example, sometimes the panel will displays 888 all the time, or sometimes the panel will not light up. For first one, if the panel can't light up, you need to check the power input of our motor. Sorry, of our driver, because for B type, you need to connect L1C and L2C, these two control power for our panel, and the L1, L2, L3, this is for power to drive the motor. L1C and L2C, these two terminal is used to power our panel. And if the panel displays 58, how to check this? First, we can we only connect cable, power input cable, and then remove all other cable, and then repower sometime to check whether it is disappeared. If not, you can connect our PC to driver by SC tool, and try to use SC tool to jog our motor. if you can jog it normally, usually it is panel question. So you can check, maybe open the driver and check the panel. Panel is connected normally or not. If it is connect normally, and for this condition, if you need to replace a new panel, you can contact us and we will send you a new panel to solve it. If you see the connecting of our motor is not good, so I think you can directly to solve it, to make it connect good and check again. This is first condition. If you can't use SC tool to connect the driver, or you can't use SC tool to jog the driver, usually it is a control board question. So in this condition, in this situation, we need to replace the driver board, replace the control boards, but not the panel. So you can see, maybe the panel have error, or maybe the control board have error. We need to analyze which part is broke. And here, second, if the panel display NOT or PLT, it means forward rotation disable and reverse rotation disable. Maybe you have maybe you it will happen if you configure these two, function code 3 and the function code 4 for the DI. Okay, and sorry, I think this title have question. This should be servo parameter setting progress. For example, when you set the parameter, the panel will flashback because this parameter is stop setting. So you need to disable the servo and set the parameter in ready status. And second, if the parameter can't be saved after power off, usually for first, maybe for this, as you remember, I said if we want to use manual setting mode for our control parameter, we need to set this parameter as 1. And the second is you didn't set P12 and 4 as 1 when you use Modbus parameter, Modbus communication. So in this condition, you need to set this parameter as 1 to make our writing value to power off safe in communication, Modbus communication. And the last is setting parameter didn't take effect. Maybe this parameter will take effect only after repower, so you need to repower and check again. This is about why the motor can't rotate normally. First is our motor can't rotate. First, you need to check the parameter setting. Maybe the control board is wrong. Maybe the control source is wrong. For example, you are using post control, but you set the control source as internal position, so it will not wrong. The motor will not rotate. And also our motor should be run in wrong status. And the next is there are no input commands of our in position control. In position control, we need to check the pulse sent by our PLC is normal or not, and we can use these two parameters to check it. U08 and U09, these two. This it will show the input pulse frequency and input pulse number. And also, if we are using speed control or torque control, we need to check the analog input is in normal range. You know, our normal range is from -10 to 10 voltage. And the last, maybe also if the motor here, if the load is too bigger or barking device didn't release, or there are some machine code question. Machine code question will also make our motor didn't rotate. But if this happens, we usually will get an error. And the last is motor can only rotate in one direction. First, we need to check the control command. It is normal or not. And second, you need to check the value. The value of our direction terminal is normal or not. Maybe check the value in correct pin number or not. And the second, maybe second reason, maybe the direction pin is burnt. For this situation, you can first check the jog function is normal or not by our servo panel or by our ST tool. If it can jog normally in both two directions, then you can contact our technical to confirm again whether the pin is damaged or not. If the pin is damaged, we need to change the board to solve it. And here, why servo driver can't communicate with PLC? First, we need to check the parameter, communication parameter. For example, baud rates, station number, and stop bit, and so on. Second, we need to check the communication ports. For VD2 series, we use CN5 or CN6 to communicate. For VD2, we use CN3 and CN4 to communicate with PLC by Modbus RS485. And then next, we need to check the communication cable, and also check the wiring of our cable, because maybe you connect AB RS485 AB order is wrong. And next, we need to check the communication address. For example, check the Modbus address, and you can check the Modbus address in our Wecon support center. They have a table, have a list about it. And the second is about the byte order of our 32-bit address. Because for some device, some PLC, maybe we need to change the endness of our 32 address. You can change it in PLC site, or you can change it in our driver site. In driver site, you can change parameter 12 and 6 to 1. Then all the 32-bit address will change. It is high 16-bit and low 16-bit. Okay. And the last, maybe in the on the bus function code is wrong, so you can check it. And here our last one is servo driver can't communicate with SC tool. For this, first we need to check the driver installation is normal or not. If it means whether your computer can detect the USB terminal. If not, you need to reinstall the driver USB driver of your computer. And second, we need to ensure we select the correct position ports. Here, VD2 and VD2F is different. And then check the cable. If you buy the cable from Wecon, it should be normal because we will test it after we sell it. But if you make the cable yourself, you need to ensure the pin number of the cable is correct. And also we have the pin number in our Wecon support center, and also in our first class, I have shown it to you. And the last, you can for this you can directly change the driver to check it. If only this driver have error, but other driver can communication normally, so it is most possibly the driver side error. So in this you can contact us to confirm again, and if it is driver side, we need to change the driver. And second is display unknown device in SC tool. For this, you need to download our newest SC tool. You have already have already downloaded the newest software, right? If this unknown device still happens, then you can it's okay. You can here right click our software and open the installation operation, and here have this parameter file, and later I will send a newest parameter file to our training group, and you can copy the this file and copy it to your SC tool installation location, and then replace the old one, and then you can check again. Okay, you can see in this parameter here have some XML, have some XML file for different firmware of different driver. So I will send this file to you later. No, sorry. If you have show this, the reading and writing will be okay, but what will happen? For example, for some parameter, is only take effects in maybe in newest firmware, but your software is too low. So after you connect, you can't see the newest parameter. Okay, but for some old parameter, you can normally to set and write it. Okay. And the function code display. Oh, for this is send. For this also we need to download the Newty, the new Newty SD tool, and also to insert the Newty is the perimeter file. Okay, so that's all our today's content, and later I will send the meeting, send the video, and we have homework today, but homework today about position control. I will put homework to you today, and also I will send this this file, this perimeter file to the group, and you can insert this to your SC tool to solve the unknown device question. Okay, and that's all today's content. Thanks for watching. And see you tomorrow. Tomorrow I will introduce our insights internal position control. Okay. Okay. See you tomorrow.